Hi friends, today we are going to see about OSPF wildcard masks. So when enabling OSPF on a Cisco router, it's like a two-step process. First, we have to enable the router process, which we enable the router process. That's the first thing. And the next thing is we have to tell that router which networks are directly connected to which networks. So it can be included as a part of the OSPF. So it's a part of the configuration work. So if you take a router R1 where we need to enable OSPF, we need to go to enable OSPF. First we go to the configuration mode and we type the command router space OSPF space process ID. Here in this example we are taking the process ID as 1, and so after we do that, we have the OSPF running, and then at that moment it also chooses a router ID based on the order it chooses a router ID. So the next challenge is once OSPF is running, is which networks we have to include in that routing process. So that's done with a command called network. So router OSPF process ID 1. So after that we have to give here as network. The network statement says that we are going to match on. So it says like we have to tell the router which is directly connected, and what we want the OSPF to do. So in this network statement we are going to match on. So first we have to match the network. That's the first step of this network statement. And then second, what we see is we have to include based on the interfaces where the IP addresses match this network statement, the directly connected network. So if we take a look at one in this example, there are three interfaces: 0, 0, 0, 1, 0, and 2, 0, and the IP addresses are 10.1.0.0 with the 24-bit mask, and 10.14.0.0 with the 24-bit mask, and 10.15.0.0 with a 24-bit mask again. So each of these networks has a 24-bit mask. So if you take a 10.1.0 network and 10.14.0 network and 10.15.0 network, the R1 is directly connected to. So for the network statement that we need to put in, the first step is we need to want the router to match on. So let's imagine that we want the router to match on the exact IP address 10.1.0.1, and we could say that okay, this router, if we have any interfaces that have this exact 32 bits, we want to include those directly networks, in this case 10.1.0 network, as a part of the OSPF. Its match and then include those directly connected networks. Now the second statement is we have the statement is like the network 10.0.10.1.0.1. We need to specify how many of these bits do we need to have the router match on, and we could say like we need to match on the whole 30-bit bits. But if we want to match on the whole 32 bits, we would use a wildcard mask that says what we need to do. And here's what the wildcard mask would say. It would say like a 0. You see here 0. It means that it cares about matching on the first octet. That's the first octet is 10. So and matching on like then again, if you the second one, it says I care about matching the second octet. If the third one, I care about matching the third, like fourth, it cares about matching about the fourth octet as well. Then so we follow with, then we have to put up like space area, and then 0 as the area 0. So we are going to use like area 0 throughout for this router 1. So we would look like at this network statement saying like I do have any interfaces that exactly match these 32 bits. So it does a quick check. Yes, as a result, it need to put the directly connected network on gig 0 slash 0, that is 10.1.0 network, to include that as a part of the OSPF. Now, the challenge with this is that if we had 15 interfaces, we have to have 15 network statement just like this with the appropriate IP address to have that router add all the interfaces. So, another way of doing this is to use a network statement under OSPF that could include multiple interfaces at the same time. So, what does that mean is every interface here starts with 10. So, what do we say is network 10, and then for the other three characters or the three octets, let's put we are like just put like we are going to put xxx, and then with wildcard mask we are going to match just the first octet, and that means like we, yes, we care about matching, and after that we are going to say it's like we are not care about what about the other. For the last three octets we are going to say just 255, which represents 8 bits, 8 wild bits, means we don't care on the on the large bits of the second octet, and 255 matter on the third octet as well. So these are called the wildcard bits. So these things are called the wildcard bits because they tell the router we don't care about those octets. So don't compare those. In this case, the router would look for any interfaces that begins with in alone. Then it would put those directly connected networks into the OSPF processor. So we also want to include again like after this space area and space 0. Now let's use another network statement again. We are going to use like 10.14.0.0 with a wildcard mask of 0.0.255.255. So again, we are going to match only the first two octets. It says like I do care about the first two octets, and the third and fourth octet we don't care. So it's only the network statement we had in the OSPF. It would include inside of the OSPF. So with this network statement, the first step is matching. The router is going to take a look and say what matches here, and based on the network statement of 10.14.0.0 with wild marks thing with doesn't care last two octets, it's just about matching on the first two octets, the 10 and the 14. Look at the interfaces here. The only interface that has the first two octets is the 10.14 is the gig 1 slash 0. Gig 1 slash 0 would be directly connected, and that will be the winner. So the network there on that interface will be included as a part of the OSPF. So now we are going to have and we'll take another example as like 10.15.0.0. It would work the same way, like the first two bits will be matched, and the third and fourth bit will not be matched. So if we take care, if you look at the wildcard mask in this one, like we are saying that the wildcard mask says like we don't care of any bits. This wildcard masks, because it says I don't care what the values are, would cause every directly connected network to match, because it says I don't care what what is the bits, all the directly connected networks will be matched. So we have told here like about the network statement and how to include the concept of a wildcard mask, and say about what we don't care. If we say 255 we don't care about, because the wildcard masks, if those bits are on the wildcard mask, it means we don't care about matching on any of the corresponding bits that are part of the network statements based on the wildcard mask saying. So we have based on this network statements and matching, that's how the router OSPF works. So these type of the we have more update on these kind of topics in one of the books that I've written, so you can have a reference of those books. I will add it in the description. If you want more videos to watch on these type of Cisco related dynamic protocols, you can subscribe to my channel, and I will get back to you soon. Thanks, guys, for watching.